Hello students, this is Miss Dalton and this video is day 2 of Unit 6. I should change that up here. This is Unit 6 and we'll be going over theoretical probability. Couple of vocabulary words that you need to understand is independent event versus a dependent event. Independent event is when the occurrence of one event has no effect on the probability of another event. For example, a family's first child is a girl, the probability that the second child is a girl is still 1 to 2. These events are independent. Now, the dependent means that the occurrence of an event changes the probability of the next event. So here's an example. The first card drawn from a standard deck of 52 is a heart. Now there's only 51 cards left, of which only 12 of them are hearts. So the probability that the second draw is a heart is now 12 out of 51 rather than 13 out of 52 because it depends on the first one. Since the first one was a heart, then that changes the results for the second draw. All right, so we're going to look at this example of flipping a coin. Now we're going to flip this coin 4 times, and the different options that we have when we flip these coins are listed below. We could have all heads, we could have 3 heads and a tail, 2 heads, a tail, and then another heads, and then so on and so forth. So this, if we count up how many total occurrences there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a total of 16 different ways that this coin flip can go. And they want to know the probability. So when you see that P out front, that just means the probability. So what is the probability that we're going to get a total of 3 heads? So let's count up how many of them just have a total of 3 heads. So we have 1 here, we have 1 here, we have here, and here, and that looks to be it. So this would be a total of 4 out of 16, which would reduce down to 1/4. Now, the next one says, what's the probability of getting at least 3 heads? So this would be 3 or more heads. So we would add to it this one. Let's see, are there any others? Looks like that is it. So that would be 5 out of 16. Okay, the next one says the probability that the event has a longest string of 2 in a row. Now this does not say whether it's heads or tails. They just want to get 2 in a row of that flip. So this one has 2 in a row. This one has 2 in a row. This one has 2 in a row, 2 in a row, 2 in a row, even though it's at the end. This one does not have 2 in a row. This one has 2 in a row with the tails. 2 in a row here, 2 in a row here, 2 in a row here, not 2 in a row, 2 in a row here, 2 in a row here, 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 or here. Okay, so if you look, that takes away only 2 of them. So that's going to be 14 out of 16, which reduces down to 7/8. That should be an equal to, not a minus. All right, now let's look at a pair of dice. So we're going to roll two die, and the 36 outcomes are listed below. So we could roll 2 1s, we could roll a 1 and a 2, a 1 and a 3, so on and so forth. These are all the different possible outcomes. So they want to know what is the probability of it adding up to 12. So let's find the ones that add up to 12. There's only the 6, 6, which will add up to 12, right? So that's going to be only 1 out of 36. Okay, what about adding up to a total of 4? Well, we're going to have this one here. We're going to have this one. We're going to have this one. And that is it. So that's just a total of 3 out of 36, which reduces down to 1 out of 12. What about a total of 7? So it's going to have to add up to 7. So we'd have this one. We would 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 have this one. And then we would have this one. So that is a total of 6 out of 36, which reduces down to 1 out of 6. Okay? What is the probability of rolling a double? So this one would be considered a double. This one would be considered a double. This one's a double. This one's a double. This one's a double. And this one's a double. So again, we have 6 out of 36, which is 1 out of 6. All right, on this next one, we're going to flip a fair coin 8 times. Now, this would be kind of hard to make a diagram of how many flips would that be total. And so remember what you learned in the last unit, where to find a total, you can do 2 to the power of however many flips you're going to have. So this would be 2 to the power of 8, okay? Now, if we're going to want to get 6 heads, so exactly 6 heads, this is going to be a combination because we can have 6 heads in any order. We just need for there to be 6 of them. And so to get this amount, we're going to do the combination of 8 choosing 6, so 8 coin flips with 6 of them being heads, divided by 2 to the 8th power. And so if you do that on your calculator, the combination of 8 choose 6, that comes out to be 28. 2 to the 8th power is 256. And if we divide that, that's going to be 7 out of 64 as our probability. Now, on this next one, it says at least 6 heads. So that means we could get 6 heads, we could get 7 heads, or we could get 8 heads. And so we're going to have to figure out the amount of all 3 of those options. So we're going to have to do the number of combinations with 6 heads, 7 heads, and 8 heads. Okay? Now when we do that, we're going to add those up. So we're going to have the combination of 8 flips choose 6, 8 flips choose 7, 8 flips choose 8, out of a total of 2 to the 8th power, and that comes out to be 37 over 256. All right, so let's go over the rule when you have, like I call them two-step probabilities, where you have the probability of one event happening and then the other event happening. So let E and F be independent events, okay? So they're going to be independent, and they want to know what is the probability of one event happening and another event. Well, whenever you have that, you're going to take the probability of the first event, and you're always going to multiply if it's an and, okay? If this says and, then it's multiplication. So an example of this would be if we have a fair die and we're rolling a 6 on the first roll, and then we want to roll a 5 on the second roll. Well, the probability of rolling a 6 is 1 out of 6. but the probability of rolling a 5 is also 1 out of 6. And since we're wanting, you know, what is the probability of both happening, then we want to make sure you multiply, and so that would be 1 out of 36. So when the problem involves and, you need to make sure you multiply. All right, so if it's a disjoint, meaning that they can't occur at the same time or they're independent, then you are going to add them together. So what's the probability of one event happening or another event happening? You're going to take the probability of the first event, the probability of the second event, but you're going to add them together. So here's an example. I have the probability of rolling a sum of 11 or doubles. Well, a total of 11 or sum of 11 and doubles, those are two separate things. They can't both occur. Well, the probability of rolling a sum of 11 is 1 out of 36. The probability of rolling doubles is 6 out of 36. We're going to add those together, and so we get the probability of 7 out of 36. So if it involves an or, then you're going to add. All right, last part is the complement of an event. What is the complement of an event? Sometimes it's easier to find the probability of something not happening and then just subtracting it from 1. So what you would do for that, and this is called the complement, is what's the probability of something not happening? Well, find the probability of it happening and then just subtract that from 1, okay? So here's an example. What's the probability of it not having a sum of 12? Not having a sum of 12. So first what we're going to do is we're going to find what's the probability of getting a sum of 12. Well, there's only one way that you can get a sum of 12, and that's if you roll a double 6. So that gives you 1 out of 36 on rolling a sum of 12. So all of the others must not be a sum of 12. So we're going to take that, we're going to subtract it from 1. Well, remember, you have to have a common denominator, so this would be 36 out of 36, subtracting 1 out of 36, which gives you this result right here, 35 out of 36. Okay, this is your assignment for today's lesson, so please make sure you're completing this in Moodle. This would be homework 6.2 in Moodle, and again, it's linked on my calendar.